Добрый день, уважаемые
Good
слушатели.
morning, dear viewership, dear listenership. AI for Planet podcast is with you. AI for Planet, Artificial Intelligence. Kirill Tokarev, Irina Sukhareva. We are hosting this studio at the key AI conference, a conference where leading coders, businessmen, scientists and engineers are discussing perhaps the quickest developing technology of modernity. Artificial intelligence, as you may have noticed, has become a part and parcel of our everyday life. The center of Moscow sees a lot of delivery robots. Our households are getting smart devices. Banking applications have been analyzing our spending and proposing options for rationalizing our budget. And the flow in social media is presenting the events interesting to us. And the web advertising is really foreshadowing our wishes, not just offering good things. It's not just the present, it is also the future that these technologies are taking care of. AI has become a tool to achieve sustainable development goals. It has been helping us to preserve our planet, hence the name for the track, AI for Planet. Together with us and our guests, we will get a glimpse of the future. Everyone will share a viewpoint of artificial intelligence, and we will together see the whole thing through the prism of sustainable development. Now, according to Nature research, artificial intelligence can assist in delivering on 79% of sustainable development goals, and most leaders of private and government sectors responsible for AI initiatives in their organizations or climate change, they also think that technology is an important tool in fighting climate issues. It is important to foreshadow the potential consequences of climate change and mitigate them before they actually occur. That's necessary to ensure the security of society and protection of the most vulnerable walks of life. Artificial intelligence can become the tool essential to make good decisions. We have in the studio Semen Budennyy, the managing director and head of the division for promising technologies in Sber. Semen, you have the floor.
Ирина и Кирилл, спасибо большое.
Irina, Kirill, thank you very much.
Позвольте представиться, меня зовут
Let me
Семен.
introduce myself. My name is Semen, and today I will try to uncover a very interesting topic with several examples. The things that have been happening at the juncture of artificial intelligence and sustainable development. Primarily, we will be talking about how AI experts see the solutions for ESG objectives. I'll be giving you a few examples now. If you look at the tandem of AI and ESG, you usually try to put yourself in the shoes of ESG experts and then AI experts and look at every facet on a standalone basis. But if you look at AI technology, it has been finding implementations for all kinds of objectives: climate, waste, sorting. And if you look at AIJ expertise, this expertise sees artificial intelligence as something that is used for optimization of computing powers, for instance. And at the juncture of these two wonderful domains, a great number of wonderful opportunities have been arising. Let me give you the examples that I promised. Let's look at the trend that we see in putting AI to use in biodiversity issues. We're going to have a report on the topic. Computer technology has learned to detect various species. We've got an interesting project for Amur tigers, where the unique coloration of the tigers is used to identify specific tigers, track them, track the entire population, and if the population becomes a rare species, various measures can be adopted to sustain the population. The most interesting thing that biodiversity
или nature-inspired
is seeing all kinds of things bio-inspired AI or nature-inspired AI.
подсмотреть
We have an emerging trend about how we can spot the laws of
AI.
living nature
Если раньше
for further use in artificial intelligence. It used to be about training models, and the job in hand was to enhance, increase the number of neurons, number of parameters. That was especially relevant for LLM models, making large models that require huge computing capabilities. And with a number of parameters, they were becoming emergent. LLM models gained the ability to translate from one language to another, despite not having been trained in this. But then it emerged and transpired that it was difficult, not just in training, but in operating them. Operating the models became energy hungry. It was now about optimization, so it was about multi-agency LLMs. Maybe we can take several. Maybe we can do an orchestration of those, and maybe we can use the ensemble to produce results on a par with the LLM results. And hence the trend that stems way in the past. This trend was about essentially mathematicians and AI scientists about looking living species self-organizing in herds, in packs. And maybe we can use those principles of self-organization of animals to orchestrate multi-agency, multi-agent systems. That's a good example of artificial intelligence going about specific issues while finding inspiration in nature. Beautiful mathematics. A very interesting topic. It is actively developing in Sber. It is actively developing in AI Research Institute, AIRI. This multi-agency systems. And then another track, the energy transition. How do you use AI to decarbonize, to lower carbon footprint? A broad range of issues is being addressed by our experts here. Specifically, we have been actively developing synthesis of new materials. And it appears that on the juncture between quantum chemistry, quantum physics, and AI, you can train large models that are not only solving direct tasks, creating materials. Reverse is also true. When we need to rationalize photovoltaic performance, we can set up an array of atoms and rationalize them in the space. Very active trend in the world. This is performing as a boosting, and the acceleration is in the orders of magnitude, because if you are honest, the quantum physics for complicated systems requires a lot of time for computing, and AI accelerates that. We have a lot of good examples here, and at the AI Journey conference, we're going to look at these examples in detail. Our community has been publishing a lot on the subject, but this treatment of energy transition is not really direct, it's more oblique. But if you look at AI implementations, applications in various aspects of energy transition, on the whole, a lot of impact has been arising. Also, the more experts we get at the juncture, at the nexus between AI and ESG, the more chances we have to see these developments implemented in industry. On the one hand, the technology, when it arises, has value, but it's quite obvious that over 90% of resources is consumed by actual development, not just research, but development. And despite this, energy-hungry solution is really resource-consuming. Our experts have been showing good progress here. Another application in AI for ESG is describing certain climatic phenomena. For instance, we have a good project together with AI Center of the Far Eastern University of Russia. That's a project that forecasts the dynamic of cyclones, their origins and their trajectory. It's a complicated job because the phenomenon of the cyclones is essentially a deterministic chaos, has hypersensitivity with a starting condition. We just can't predict the weather several days in advance, not because we've got weak models, but because we've got weak conditions, because sensitivity is great for them. In several iterations over time, the scenarios can change. If the beginning condition can change 1,000%, that's just one issue here. There are many more undercurrents, many more pitfalls here, but computer vision and predictive technologies can use spatial photography to detect the origins of cyclones and do all the rest that we need to do. Precision has been increasing, and the horizon of time for predictions can be increasing as well. Why do we need this? Apparently, if we can forecast the risks, physical risks we are talking here, we can mitigate those risks in advance. We can allay the consequences. Cyclones are frequent, not just in the Far East. Cyclones happen worldwide pretty frequently, and the scientific community is seeing great relevance in good descriptions and in good predictions for cyclones. That's another example of things that we have been successfully going about. And we're actually having an agreement with the Russian Emercom that this model that we developed with the Far Eastern University AI Center will be actually used to work with the cyclones in the Far East. Another example here, a good example of what we can do at the juncture of AI and ESG, is something that I mentioned at the outset of my speech. I said that it's often useful to put yourself in the shoes of an ESG expert and look at AI for optimization. One of the reasonable objections was the resources. AI is energy intensive. Last year, we created an open library to train, to track CO2. Our research showed that this metric is a good touchstone for efficiency. AI community, DS community, usually compares a model to a certain benchmark, and the entire community is really competing versus a certain benchmark. Narrowly speaking, this metric appears to be a SOTA, state-of-the-art, but if you add the energy efficiency to this, then you can look at the model from a slightly different viewpoint. You can look at the incremental precision improvement, how much 1% of a precision increase costs in energy efficiency, specifically with CO2 emission. We did this. That was a model that proved pretty popular, about 15,000 downloads worldwide. It is pretty pleasant for us that this model has been gaining popularity, but tracking for the sake of tracking is probably not what does the trick for us in sustainable development. So we optimized, we made it an open source model so that all the community can use it. And this is a forecast, an eco-forecast model that can use cloud computing when we'll launch large models in the clouds. It can dissect the training across several physical servers in different regions in a way that, over the course of training, the energy efficiency is actually optimal in terms of CO2 emission. It is famous that to generate 1 megawatt of energy, the emissions constitute between 100 and 500 kilograms of CO2. And if we look at the various regions and their computing clusters, with knowing, say, 24 hours in advance what CO2 capability is going to be, and it does depend on the time, we can split around the regions with CO2 becoming the lowest. And it appears that we can actually rationalize about 90% of CO2 emissions in the course of training. Obviously, not every model can be run in parallels during training, but some bits of engineering jobs, hyperparameter optimization, those things can be run in parallel across geographically diverse regions. We did this model, eco-forecast, and here again we came a little bit closer to optimization. We have developed large AI models with concern for energy efficiency, and we have been developing the ecosystem of such libraries while making them open source. And hopefully this zoo is going to give us some synergy effect. And perhaps the last example here, we developed this together with an AI lab of our ESG directorate. It was a pretty simple library, but very important. It allows us to identify the ESG risk based on a certain text. A very important job this was, because very often we get the need to process colossal volumes of text. That can be text on companies reporting ESG, on ESG performance. It might be some kind of a news digest, some kind of a public domain information. And it's very important to be able to identify this text for ESG risks inherent in it and identify the class of that. We obviously have three kinds of risk: environmental, social, and governance risks. But then there are further levels of classification. So we did an NLP model based on this architecture. We filed an article and we made the library, again, open sourced. Anyone willing can use this worldwide, integrate this library into business processes in the company, or perhaps in the daily routines, just day-to-day routines. Again, this is a tradition with us, doing things on an open-source basis, not just for AI professionals, but for ESG professionals as well. We would like these libraries used, and hopefully we can produce some kind of a good effect for that. Now, in summation, I only cited several examples of things happening at the juncture of ESG and AI. Perhaps three things in summation.
First of all, AI and ESG combination is still emerging, and the experts that know both areas are not that many. It's not a red ocean, really. It's a greenfield. And obviously, it would be great that this topic continues to be on top of the agenda, because the ESG has quite a wide agenda. It's very important to say that now we're living in the generative AI era. We used to live in the weak AI era, but now the strong AI, generative AI, can create new knowledge and resolve multimodal modular tasks. Now, the potential of implementing the models in the ESG tasks, as well as the achieving the ESG goals, is, I subjectively think, still there. There's still a lot of room for improvement. LLM models, transformer-based LLM models, or even more complicated generative structures could be applied, and I think that's a great growth point. The third point is that the advantages, especially in terms of the environment protection, is serviced by AI, by describing the physical world and some difficult natural events, and the stats have to be in line with the physics of the processes, and here it's very important to attract experts from various fields, like physicists and theorists, climate experts. AI and ESG interdisciplinary knowledge, but the combination of these two areas that need more diverse experts, and we need to create more hybrid approaches. We need to make sure that data science works together with physics and the physical principles, and this is a very good emerging trend that is popular among the physicists and the scientists, data and ESG communities. Now, summing up with these 3 points, I would like to say that this AI and ESG tandem is a great opportunity for synergy for the development of these science and achieving sustainable development. Next, reports will provide you more details on the topic. I hope that you will find something useful for yourself, and I hope that our community will grow. Our ESG AI community will grow, and we will make you happy with all the new presentations and reports. And while always keeping sustainable development goals in line. Kirill, Elena, the floor is yours.
Спасибо, Семен. Абсолютно солидарны и надеемся.
Thank you, Semen. I hope that our video cast will inspire the leaders to create new things. The synergy of ESG and AI. Now we're having Vladimir Vanovskiy from Skoltech, MIPT. Vladimir, nice to meet you here. Hello. So you are the head of the research group for the applied artificial intelligence, applied AI. How can it monitor the climate change and control these processes? Building the climate models. What are the best practices here? Something I can talk about, that's true. This is one of the focus areas of our center, modeling with AI for the complicated natural mechanisms of nature, and there is a big layer of research that goes back from 17th century. Benjamin Franklin, who was a mathematician and physician, he was making first forecasts. Then some Americans modeled the weather in a way. There was the team from the nuclear project, and then dozens of petaflops are used to model climate and weather. And AI is needed here, first of all, because the physical models, they have their limitations. They are very expensive, compute-wise, costly compute-wise. So we can accelerate these models, and the majority of our solutions is focused on that. If you're interested, I can tell you the details on the applications. Maybe there is some showcase application, because these models, they become more energy hungry, they become more complicated. But where is AI here? How can it help to make it more efficient or quicker? Yeah, there is a weather regional forecasting model. This is the model that is used in Russia by Yandex and the meteorological agency, but it is very complicated. And if we increase the tenfold resolution, we should have more than 1,000 clusters, and one cluster is like a couple of dozens of kilometers. So the resolution, as the resolution grows, the complex nature of the model grows. So if we want to look at the urban quarter with like 2-3 kilometers wide, we can't use the simple model. We will need to take the weather forecast in one resolution and transfer it to the weather forecast in another solution that would at the same time have some physics, maintain the physics of the high resolution, so that it's not just an interpolation. Another idea is that all complicated models, they have the parameterization in them. So it's very hard to calculate the turbulence. The turbulence can be translated into from several microns and until several hundreds of kilometers. If you talk about like cyclones, for example, and AI is the kind of an approximation solution. So it really is. It really aligns with these parameterizations, and you can calculate in a more efficient way. Now, parameterization of the solar radiation, that's a very energy-hungry part of the model of the weather forecasting model, but it is possible to make it more efficient. I would like to move it back to the more applicable, more understandable level. We know that there are two major global climate threats. Melting ice in the Arctic and the ozone layer. Now, this melting ice is affecting the agriculture and many other things. Your models, what do they show in terms of melting ice in the Arctic? Well, that's great. We are in Russia, so the ozone layer is working pretty well, unlike in Australia, for example. But the ice is very important for us, and it's not only a climate challenge; it is a set of opportunities. If you look at the example and this photo, March, it's taken in March, the volume of ice is maximum, and you can see that the white ice is the thick ice, and look at how it diminished. The Arctic is still full of ice, but it's thin one-year ice. And many scientists believe that the surface of this thin ice will decrease as well, and maybe in summer, in some parts of Arctic, there will be no ice whatsoever. And that's a major climate change, because many animals, they are accustomed to the fact that the ice is everywhere, but now they will have to travel to other regions to find this ice. Now, the Northern Seaway, the new Northern Seaway that is opening, that is emerging. Quite a lot of cargo can be delivered from China to Europe, or from, for example, Japan from Europe. It will be able to decrease the logistical costs by 1.5-fold, and obviously that will also drive down the CO2 emissions, as well as the transportation company costs. Now, if you look at the other slide, this is what we do in terms of the trying to fine-tune our expectations in terms of, like, we are forecasting in the Arctic. We're using sat images for the forecasting. On the right-hand side, you see the forecast with the classical quantitative methods, and the ships can get stuck in the ice if they don't have the relevant information. They might go to this. They might find out themselves in the ice field, so to speak, and they will have to be stuck there for like 6 months if there is no icebreaker around. Now, how do you actually address that challenge so that the cargo is delivered on time? Well, you need to ensure the good forecasting so that you can plan the icebreaker and ship schedules properly. Now, the permafrost that is melting, Do you look at that with your applied AI solutions? Well, yes, that's some people think it's an exotic problem, but not many people know that 2/3 of the area of Russia, if you look at the slide, by the way, that really shows you everything. It is related in that way or another to permafrost. And many buildings, many factories and mines, and sometimes even towns, they are being erected on the permafrost, which gives certain density, obviously. Obviously, when it melts, the buildings start to crumble, as you can see it on the photo. And that means economic risks that are quite high. The environmental risks are very high, because if you look at some oil storage factory that will go to Earth, well, nothing good will happen from that. So the solution that is used, and the team that is used for permafrost melting forecasts is working for Sber as well. A very kind of a newbie question about permafrost. Can we control that without thousands of sensors? To create a center for monitoring of permafrost, you need to measure the temperature across the buildings. I mean, we have a huge country. Is more than 60% of the country is within the permafrost areas. So how can you put all these sensors there? But is it only sensors that can work? Can we use AI not to do that? But we need sensors and the people who are going to maintain them. That's a great question, Kirill. Thank you very much. We do need sensors. They are important. As a physicist, I can say that experimental data really crowns any efforts in physics. There's a lot of theory that is built around the theory of data. A theory of Kudryavtsev is used for the permafrost forecasting. If you have characteristics of permafrost in this or that region, like there's some permafrost map, you can model how this map is going to evolve. Season-related evolution will be taken into account, and obviously you can model that. Now, there are some attributes. If you talk about AI and ML, the best thing there is that we have a huge number of indirect attributes, like we're looking at the plants, we're looking at the temperature of the surfaces. If you load all that and use some deep convolutional network to look into that, it can give you a pretty good predictor for the permafrost. Now, some general questions. What other climate challenges your applied AI center addresses? And what are the challenges that you define and monitor, which is maybe even more important? Yeah, well, I talk about another thing that is quite controversial. Global warming. And, like, there were many periods like that of global warming. But how does it affect people? And the climatic risks like earthquakes, that should not really depend that much on the warming, on the global warming, or maybe some fires, some floods, extreme temperatures. All of the cases like that increased manifold, natural disaster cases, and the risks increased manifold. 50 years ago, we were living in this quiet time, but now the climate is being disrupted, and this is why we hear a lot about the floods, about the fires, not because the news are ubiquitous now, no, because the cases like that increased in their numbers. 50 years ago, there were the first satellites that were sent to space to monitor that and to monitor the earthquakes, for example. The earthquakes have been monitored for a long time, but the frequency of these events increased. increased dramatically, and in our center we forecast a lot of risks like that. We are doing it for Sberbank. We also had some partnership with the Russian Ministry of Emergencies. So there is a task to forecast these risks. Monitoring, not forecasting, monitoring. Like we had a flood or fire. We have to understand what is the area that has been affected, how much forest was burned, how many buildings were affected. It is now done with AI. And if you use the quantitative selection, then you can process that automatically, and you can make the life of the people who analyze the consequences and forecast them much easier. Another interesting and promising topic is fire forecasting. We have a lot of fires, a lot of forests in Russia with fire hazard. So we need to understand how to extinguish the fire in these forests and how to address the ramifications of this fire. So we use a lot of predictors, like the temperature in the plants, to predict the fire. And these predictors can be determined through the sat images, and then you can predict where the fire will actually start. But if the fire has started already, we can predict how can it spread, given the wind, given all the other indicators. And this is the picture that shows you how it spreads with the counters. That shows you how it was spreading on the third day, and actually the model is pretty good. It helps you to show you the spread of the fire.
If we talk about other things that we have been doing, they are more about environment. That was just my next question. These models can be used to study all kinds of things, pollution, air pollution, all kinds of emissions. It should be potentially in great demand on the part of the business or the government. These are good words, actually. We're also looking for great demand on the part of the business and the government. We have been starting to fight emissions with much greater activity. Legislation has been emerging, and the businesses have this problem in hand. They need to control emissions so as not to face pretty stringent fines from the regulator. But you can't put a sensor on every pipe. How do you control the emissions if you're an outfit? You can do this indirectly. We proposed this technology. We actually implemented it. Say, around a factory, there are certain emissions monitoring stations in the center of the city, and they are detecting elevated concentrations. We can also model the wind maps. We can plot the wind directions, and emissions really spread with the wind. And the third picture on the left, this is the reverse trajectory. We can model the reverse trajectory, and from every source that stated certain emission, we can model, and we can also model from the station that did not state any emission. This is really reminding us about the novel by Sir Arthur Conan Doyle about the dog that did not bark. If the station did not confirm any emission, this is also information. So we unite all this information and we gain pretty accurate picture of the direction of the emission and the amount of it. We can actually state what emissions happen and where, and this information is either necessary for the outfit to eliminate the emissions in good time, or the regulator needs this information to mete out the fines in good time. Well, hopefully we do not end up with the fines. We need lower emissions and not more fines. Well, thank you very much. Thank you, Vladimir, for your insights. Well, the main conclusion, perhaps, is AI technology has been giving us colossal effect, helping us to preserve the planet and deliver on the sustainable development goals. And the next topic, we're going to look in greater detail into a highly relevant issue of energy transition. The first thing to say, AI is relevant. Elena, have you heard about energy transition? You will not believe it. Probably everyone has. Just to give you a reference, energy transition gives you about 100,000 hits in the search engine. Yeah, clean energy is probably going to give you much fewer. Okay, stay with us. Small music break, and the music was written by artificial intelligence. It's Informer, Your Network by Sber, obviously.